Welcome to Student Teaching Math 217 with Professor Brian Church. This is the logistic function. Now, a logistic function is mostly used to model demand for new products or technology, or to model epidemic or population figures. The function here we have is f of x equals n over 1 plus ab to the negative x. Now, n, a, and b are all constants, with a and b being positive and b not equaling 1. N, in this case, is the limiting value or the ceiling value of the function. So what that means is that the number that n is, the function will not go higher than that number. Now, the graph of a logistic function is an S-shaped curve between the horizontal lines y equals 0 and y equals n. Now, if b is greater than 1, the graph will rise, but if b is less than 1, the graph will fall. And here we have an example of both graphs. The graph on the left, b is greater than 1, and as you can see, it rises, and the graph on the right, b is less than 1, and therefore it falls. Now, the y-intercept of a logistic function graph is modeled as n over 1 plus a. So this will be your starting value. And the curve of a logistic function graph is steepest when x equals the natural log of a over the natural log of b, and y equals n over 2. So we can see here that the n graph will look a little something like this. Now, this is if b is greater than 1, because as you can see, it's rising up. So right here, we have our y-intercept, n over 1 plus a. That'll be our starting function. Here in the middle, we have our point where the graph is the steepest, the natural log of a over the natural log of b, n over 2. And as you can see, it goes up to n, but it never touches that because that is the ceiling value. And that is the logistic function.
Example 1, you own a rubber band company with 150 million rubber bands in stock. There are 10,000 sold already. The number sold doubles every 2 weeks. Use logistic function to model the number sold. Also use the model to predict when 1 million will be sold. So starting off, we need to set up our projected model. That is P of t equals n over 1 plus ab to the negative t. Moving on. We know that n is one of our constants, and that's 150 million. That's our limiting value because we can't get any more rubber bands than that. That's just where we're at. We've got 150 million. That's what we're working with. Can't go any more. We know that when t equals 0, this is what it will be set up like. T equals time. So in this model, when time is 0, we got 10,000 equals n over 1 plus a equals 150 million over 1 plus a. 10,000 being the rubber bands already sold. So next we need to solve for a, and solving for a, things get pretty easy. Okay, so it's 10,000, which is the rubber bands already sold, times 1 plus a equals 150 million. Now this is just algebra. It's 1 plus a equals 15,000. That's 150 million divided by 10,000. Then we get 15,000 minus 1. That's 14,999. Then we get a equals 14,999.
Next, we solve for b. So you pick 2 points. The x's represent 0 and 2, which is time, while the y values represent 10,000 and 20,000, which is your rubber bands sold, which would be y equals 10,000 times the square root of 2 to t. So for b, that would give you the square root of 2. Now, you solve for the logistic model. So P of t equals 150 million over 1 plus 14,999, which is what we got when we solve for a. You times that by the square root of 2 to the negative t, and that will give you the logistic model. Next, we're going to figure out when 1 million rubber bands will be sold. So we take 1 million and set that equal to 150 million over, like the equation we got up here, 1 plus 14,999 times the square root of 2 to the negative t. So we bring that down, set the equation equal to each other, equaling 150 million. So 1 plus 14,999 times the square root of 2 to negative t equals 150. Bring that down again, 14,999 times the square root of 2 to the negative t equals 149. So the square root of 2 times t equals 149 over a, which was, like we said, solved, which was 14,999. Then we set that equal to negative t, which equals the logarithm of the square root of 2 times 149 over 14,999, which will equal negative 13.31. Now these are both negative, so they cancel, and we get 13.31 for our answer, which is the number of weeks before we hit 1 million rubber bands sold.